Okay, now what we are going to do, we are going to study today the chi-square test, isn't it? And how this chi-square test we can use in biology. Now, in chi-square test, now, for example, in biology, normally we use this chi-square test for biology in genetics, whether one thing is linked with something or no. Okay. Now,
Yeah.
once we are talking about Mendelian traits, yes, Mendelian traits. So there is there are two laws, yes, law of segregation and law of independent assortment. Okay, law of
Yes.
segregation is monohybrid cross, yes, where what is the outcome according to the law of segregation? What is the outcome? Outcome is 3:1 ratio, yes. Out of 3,
Yeah.
this will be 3:1 ratio. The recessive will be available in F2 generations, this number. Yes, 3:1 ratio. Then comes
Yeah.
law of independent assortment. Here this is actually dihybrid cross, where at one time we are studying two characters. Yes, two traits
Yes.
we determine, we observe two traits simultaneously. So what is the ratio for dihybrid cross? Dihybrid cross is 9, 3, 3, and 1, isn't it? So
Yeah.
this is 9, 3, 3, 1 ratio. Now the point is, what does it mean? Before I go into the detail, you just remember, for example, if I have 40 plants, okay, 40 number of plants are there. If I go for this ratio, which is mentioned, okay, this law of segregation, monohybrid cross, then there should be 30 should be the dominant, yes, with the dominant trait, homozygous or heterozygous dominant, and 10 should be recessive, correct? So this is 3:1 ratio. Now, this is what? This is expected ratio. We call it expected. We are expecting that out of 40, this is, it should, the number will be 30 will be the dominant alleles and 10 of the population will be recessive. Okay, this is expected number. Now the point is, this is just expectation. Okay.
Yeah.
Sometimes, for example, one couple is there, okay, and that couple is heterozygous for one trait. For example, cystic fibrosis. Okay.
Okay.
Cystic fibrosis, the couple is heterozygous. They got two kids, and both the kids are normal.
Yeah.
They're actually, they should be having kids which are normal, plus they should be having at least, what would be the percentage of abnormal kids with cystic fibrosis? 25% of the kids, they must be recessive. Yes, they should have disease for this couple.
Yeah.
This is our expectation. Yes, but they got 4 kids and 4 out of 4 they are normal. Technically, what is our expectation? Out of 4 kids, minimum 1 kid should be with the disease. Yes. Sometimes the same couple, they got 3 kids now, or 4 kids. Okay, keep the example simple. Again, the same couple, they got 4 kids, and 4 out of 4 they are diseased. They are homozygous recessive. So this is, so there is a difference in expected and observed kind of traits, correct? This is so chi-square test will give us information how to justify this thing. Okay, how to compare expected results with observed one and give the reasoning whether this is significant or whatever. Okay, that will come towards the end. Okay, now once we are talking about this one, the chi-square test now. So dihybrid cross. I have a data with me, okay? Now I'll share you that data. Just hold on. Just bear with me, okay?
Okay.
If you see this data, now the yellow seeds are crossed, a yellow seeded and round, a yellow seeded and yellow and round seeded plants, they were crossed with green and wrinkled seeded plants, correct?
Yeah.
So ratio should be what? Ratio should be 9331. Yes or no? So this
Yes.
is the actual number. This is the observed number. How you
Mm-hmm.
get the observed number? You will you will get the within the question, it will be provided that these many are
Okay.
yellow round, these many are yellow wrinkled, these many are green round, and these many are green wrinkled. You will get this number either in the data provided or in the question it will be given, correct? Then what you
So
will
you
do,
never need to find.
I'm sorry?
So you never need to find the observed.
No, for example, if you
Okay.
need to find out the observed one, for example, if this is missing and they have
Yeah.
given you this
Then
number,
you just subtract. Okay.
so then, so it cannot be like they did not give you this also, and they did not give you this also, and they're asking you, please give how much will be observed. Then what you can do, you can put this number there, because or this number should be the same one, correct or no?
Yeah.
Yeah, so anyway, the point is, if, for example, they have not provided you this number and they are not provided you the total number also, then what you will do with this number, you will multiply it with 9. So whatever the number will come, you'll get this number.
Okay.
It's up to us. This is, jingling with data, correct? Normally what
Yeah.
happened in the question, they provide this thing straight away. They provide
Okay.
straight away. Okay, so what you will do,
Yeah.
they may not provide you this. Okay, so they just
Mm-hmm.
provide you these 4 different kind of expected results. Okay, so all of them, once
Okay.
you add them together, this you will get 560. Yes,
Yeah.
this is your observed one. What was expected now? How you'll get the expected? Can you tell me how you will get this 315? Tell me. Solve it on my screen.
I'm not sure.
Okay, now this is very easy now. For example, what is this? Here it was 9. It should be 9 upon what? 16
Through 16. Yeah.
multiplied by 560. Can you do this calculation for me?
Yeah. 1 minute. Yeah, that gives 315.
You got my point now. So if you want to
Yeah.
get this number, so what will be this number? It will be 3 upon 16 multiplied
Mm-hmm.
by total number. So technically you are
Yeah.
right, actually, Sia. This was a big thing for you. Savala,
What?
this question was difficult, yes? Because no idea,
Yeah.
yes? Anyway,
Yeah.
so here, so you'll get this number 105, you'll get by 3 divided by 16 multiplied by the total number. So maybe they will just provide you the observed one, and they will, even for the observed one also, they may provide you only this number, or they may provide you only this, or they may give you only this. If they give you only 96, then how will you count? So 96, first you have to divide it by 3. So you will
Yeah.
get one number. Yes. So for
Yeah.
example, so one will be equal to what? 3 and 2. 32 will be the number. Yes. Then
Yeah.
32 multiplied by 3, you'll get 96. 32 multiplied by 9, you'll get these numbers. Yes. So it depends.
Yeah.
This is manipulation of data. So this will be observed one. So they can give you data of any kind. Okay.
Okay.
After getting, now you got it, like how to get the observed one and how to get the expected one. So there is a difference between observed and the expected. Yes or no?
Yeah.
It is clear?
Yeah.
Okay. If you want, you can copy this data because this data is the more, this is the key actually. If you remember this data, you can explain anywhere. Okay. Better, I suggest
Okay.
you copy this data. Normally, I don't ask.
Okay.
Yes. You copy this data.
Yeah.
Data, just this data you copy. Once you are done, please tell me.
Okay. 1 minute. Okay. Done.
Okay. Now, once we are after that, once this data we got, then there is next data. Okay.
Mhm.
You have to go with the next data. Just 1 minute. Now you see this data now. What is the chi-square test? What is the equation for the chi-square test? Equation is x square is equal to
Yeah.
what?
Observed minus expected
Observed
over
minus expected
expected
square.
over expected.
Yes, it is
Yeah.
square
Yeah.
divided by
Over expected.
yes, and actually this is
Yeah.
the sum of. Okay, this is the
Okay.
sum of. Okay,
Yeah.
sum of. So this is the chi-square test. This is x square is equal to sum of observed minus expected square divided by the expected. Correct? Now, if you see
Yes.
observed values, the last one, what you did, you have these values here. Yes. Then you have the expect.
Yes.
What should be the expected value? Yes. Then what is there?
Yeah.
Observed minus expected. So what is the difference? Difference you got here 13. Correct? Here you
Yes.
got it -9. Here you got it
Mm-hmm.
-6. And here you got it 3. Please copy this data.
Yes. Okay.
And after copying this data, please fill in this also.
What do I need to fill in?
First of all,
Okay.
no, one is solved for you. Yes, the first one
Yeah.
is solved already. Yes, because already you
Yeah.
copied this data. Yes, you just have to draw
Yeah.
this column, and this column. Okay, and then
Yes.
one is solved for you. Yes, OE square
Yes.
divided by E is there. Yes, one is solved for you. So you solve these
Yes.
three values, please. You have calculator with you?
Yes, I do. Okay.
Give me the values here.
So for that one, it's 0.771.
Write down, write down. Can you write on my screen?
Uh,
Type, okay?
okay. How do I?
Typing, I think you tried before.
Yeah.
Click on top, on
Yeah.
up annotation
Okay.
tool is there, yes?
Oh, did it work?
Yeah, I saw it. Yeah, next.
Okay. Okay.
Very good. Now add them all. And give me the answer.
Okay. Yeah.
Okay, this is 1.822. Okay, yellow. Now this is the x square value. You got it. Okay.
Yeah.
Now, till this, there is no confusion now, correct?
Yeah.
Okay. I'll be moving next now.
Okay.
So your answer is almost telling here. Okay. It is telling.
Oh, what I did was I rounded it for like the values in the table,
No
but for
problem.
the
So it
sum,
is
I just
1.821, whatever. Okay. Or
okay.
1.822. Correct. It answer is correct.
Yeah.
There's no no
Okay.
problem.
Okay.
Okay. Now this, the values we got them. Yes. After that, what
Yeah.
we need to do? Where is that gone? Yeah. Now, please, this is the most important part now. This is the thing that you need to understand, okay?
Yeah.
In this whole thing, this is the most important thing, okay? Now, please remember,
Okay.
this is the probability. Now, if I ask you for the data that you made, what is your null hypothesis? Null hypothesis what means what you are going to expect according
Yeah.
to the best knowledge available or according to your best understanding. So what is your null hypothesis? The phenotypic ratio in this cross, in this dihybrid cross, must be 9:3:1 ratio.
Yeah.
Correct? This is
Yes.
your null hypothesis. Now,
Okay.
if you get that data as, if your data that is being provided is actually matching with your expected results, then it's mean your hypothesis is correct. This is the important
Okay.
point. Okay. For example, the data that you got, if that data exactly describes 9:3:1 pattern, it's mean your data is correct. But in normal,
Okay.
and if data is not matching, then it's mean your null hypothesis you have to reject because there is a difference
Yeah.
in the observed as well as in the expected results. Now,
Okay.
one most important thing in this whole kind of problem, you must remember, obviously, once you are expecting and once you are getting the observed data, so there you cannot get 100% the same results, what you expect and what
Yeah.
you are observing. Yes, there will be a
Yeah.
difference. So chance of doubt, probability must be given, like, okay, if data has a range of this difference, this is acceptable. And if the data exceeds then this much difference, it's mean it is not acceptable. This is very
Okay.
important statement I told. Okay. If the
Yeah.
difference exceeds, so there is a limit of probability. Okay. Different subjects,
Okay.
they have different levels of probability. In biology, normally we take the probability of 5%, 0.05.
Yeah.
Okay. So any data
Okay.
that you got, if the probability, the net result falls into less than 0.05% difference, if it is there, it's mean your data is very good. Null hypothesis will be accepted. It is correct. But if
Okay.
the value of probability exceeds 0.5 value, 5% and more, 5.6, 5.7, 7, 8 or 9% difference is there between expected and observed, it's mean there is a significant difference. Okay. There is a significant difference between expected and observed. So null hypothesis will be rejected. This you have
Okay.
to write in your own words. Write on.
Okay. So if the difference exceeds 5%, then the null
If the
hypothesis is rejected.
probability, if the probability is present in between the 5%, 5% probability means if the difference between the data of expected
Yeah.
and observed does not exceed 5% probability, 5% change, the difference is not more than 5%, less than 5%, or up to 5%, the null hypothesis will be accepted. Why? Because that difference is not significant.
Yeah. Okay.
But if that, then the next statement will be vice versa. You understand? We don't need to explain now.
Yeah.
If the difference exceeds 5%, 0.05 of the probability, then
Yeah.
this difference is significant difference. So we can easily say null hypothesis does not meet the criteria. So null hypothesis is rejected.
Okay.
This thing is clear, yes? So probability
Yeah.
for biologists is 0.055%.
Yeah.
Now, next thing is, there were how many traits in the data? 4.
4.
Number was, and if I ask you number, it was 4. What was that 4? Yellow
Yellow,
round,
brown,
yellow
green.
wrinkled, green round, green wrinkle. There were 4, yes?
Yeah.
So degree of freedom, what is the degree of freedom? You can make degree of freedom, you will get after minusing 1. So degree of freedom
Okay.
will be what? 3.
3.
Correct? In
Yeah.
3, you got, what is your value? You got the value of 1.821. Correct? So this is the
Yes.
degree of freedom. In 3, your value is this. Where does it go? Okay. So here, if you
Okay.
see, it is present where?
Wait, sorry, what?
This value,
Yeah.
1.82, it falls into which category? Okay, no, before I go into next stage, okay, just 1 minute, okay. Your data, the value that you got, it should be what should be its value? It should be 7.82. If the
Why?
value that you got, this means 0.05% at the degree of freedom 3, the value should be 7.82.
Okay.
You get this point?
Yeah.
For the degree of freedom at 5% difference, the value should be 7.82. If
Yeah.
your answer is less than this value, what does it mean?
It means that we reject the null.
We will, no, we'll accept the, if it is less than 7.82,
Oh, okay.
less
Yeah.
than
Oh,
7.8,
okay.
correct?
Yeah, yeah, okay.
So what does it mean? It means you will be, we will say, this is what we call it, this is null hypothesis will be accepted because this
Yeah.
value does not exceed 7.82.
Okay.
This is very important. You'll be writing in your own words. But
Yeah.
if your value, this x square value, it exceeds this number 7.82, it's mean this difference is significant and null hypothesis is rejected. We call 7.82 as a critical value.
Okay.
So critical value at 1, what is the answer? At 0.05.
Mm-hmm.
My question is there. What is the
Yeah.
critical value
Yeah.
when the degree of freedom is 145%?
When the degree of freedom is 145?
Yes. What is the number? when the degree of freedom is 1, what is the
Yeah.
5% probability? What is the value of, what is the critical value?
3.84.
Yeah, yalla. Now this is the answer. You understand how to read this
Yeah.
table? Now you got it, yes?
Yeah.
When the degree of freedom is 0.02, when the degree of freedom is 4 and
Mm.
probability is 0.02, what will be the critical value?
11.67.
11.67. This is the way of reading this data table.
Okay.
You get it? So
Yeah.
whenever you get any critical value, this critical value, if the number is less than that critical value, it is null hypothesis get acceptable. If it is above 7.8 toward the critical value, it will be rejected. This is
Okay.
the rule. Can you
Okay.
please write this thing?
Yeah.
I think your problem I solved now.
Yeah.
Yes or no?
Yeah. Okay. Yeah. Done. I've written it.
No. So now the null hypothesis means the real one, which is according. What is the opposite of null hypothesis?
Hypothesis?
Null hypothesis.
I don't know what the opposite is.
Okay. Null. Okay. You know the null.
Yeah.
Who is null?
Like what?
Who is null?
I don't know. What? What do you mean who
Null.
is null?
Yes. Who is null? Null was
I'm
a
not
scientist.
sure. Okay.
So he created this kind of problem for us. Okay.
Okay.
I mean, maybe statistic. He was a statist. What we call, there is one physician for statistics person. What we will call it?
I'm
The
not
word.
sure.
I was also not sure. So Null was a scientist. Okay. So he
Okay.
proposed this thing. So whatever is falling under our hypothesis, if it goes in line with our expected statement, it is accepted. If something is going beyond this thing, it is rejected. Yes. So once
Yeah.
the null hypothesis get rejected, then there is another hypothesis. We call that hypothesis as alternate hypothesis.
Okay.
Alternate is not the name of any person, okay?
Okay.
So I want to make it very clear for you. Null was the scientist, but alternate means then you have to modify your hypothesis. For example, you said, I'm expecting 9:3:1 ratio. If 9:3:1 ratio did not come, then you have to modify the statement. Okay. So that
Okay.
statement which will make, that will be alternate hypothesis or opposite of null hypothesis. I will not
Okay.
get in this particular trial, I will not get
Mhm.
9:3:1 ratio. So
Okay.
this is the alternate hypothesis. Okay.
Yeah.
Now, most of the things which were related to this topic, which was chi-square test, we have done it. So
Okay.
in this
Yeah.
chi-square test, it is applicable in order to figure out whether our expected results and observed results, they are matching or not. And normally
Okay.
we use this thing in genetics. This is the
Yeah.
first part of your question. Okay. So now this
Okay.
whole thing we understood. So
Yes.
now next thing is, I will stop it here now. Okay.
Okay.
This one, just 1 minute. Recording is still going on, or it is still going on? Yes.
Yeah.
Yeah.